Here we have an example in which we're trying to find the cosine of alpha plus beta. Let me write that out for us. They want us to find the cosine. I'm just going to make it a plus b. So that's the question. Find the cosine of alpha plus beta. Well, how do we do that? Well, I'm just going to go down and get the formulas from adding two angles. So if we come on down here, here's the formula sheet for adding two angles. Cosine of two angles added, there it is. Cosine of x plus y. Notice the sign here, plus or minus, minus or plus, upside down there. For the cosine formula, the sign switches. It's opposite. Okay, let's go write that down. So be careful to get that exactly right. It's cosine, cosine, sine, sine. And we go A, B, and this plus or minus becomes minus plus, its opposite sign. Okay, so yeah, so they have plus. Yeah, so I can just go ahead and we don't need both versions. We have plus. They gave us plus. So then this right here is going to be minus because it's opposite sign. Okay, so what can we do here? Well, they're telling us this right here. Bring it over here. Says the cosine of A, cosine of alpha, is square root of 10 over 9. And this over here says the sine of B, of beta, is square root of 3 over 9. So, okay, so what does that mean then? Well, I know cosine of A, right here. It's root 10 over 9, right here. And I know sine of B, I know this guy is root 3 over 9. It's right there. What I don't know, what I need to know, is this, what's cosine of B and what's sine of A. How am I going to find what those are? That's where I'm at now. I need to find those two, and then I can finish this problem. How do I find those two? Well, you're going to need to draw a triangle for both of them. So this is where things get a little involved. Notice it says first quadrant angles. So I'm going to need to draw these things in the first quadrant. So here we go. I'm going to make a first quadrant angle and a little triangle right there. Same thing over here. I'm going to have one triangle for A, one for B. So this one over here will be the A triangle, right? It's all about A. This one over here will be the B triangle. It's all about angle B. So one triangle that has angle B and one triangle that has angle A. Because they're different triangles with different facts, different truths. We're really talking about two totally different angles in two totally different triangles. So step one, draw, not drawn. Let me try that again. Step one. Draw first quadrant two triangles, A and B. We have an A and a B triangle. Step two, use the Sohcahtoa facts. What do I mean? Well, in the A triangle, remember Sohcahtoa, cosine is adjacent over hypotenuse. So that means this is adjacent and this is hypotenuse, right? So remember, we go, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So the adjacent is root 10. So this is root 10. And the hypotenuse is a 9. Right? It says right here, hypotenuse is 9, adjacent is root 10. And then in the blue triangle, here is again the opposite side and the adjacent side and the hypotenuse. Okay? And what does it say? It says for sine, opposite over hypotenuse, this is opposite. For B, for angle B, the sine opposite over hypotenuse. So the root 3 is opposite and the 9 is hypotenuse. Root 3 is opposite and 9 is hypotenuse. So notice we have two parts of each of those triangles. We're missing one side in both triangles. How do we find that missing side? You know, a squared plus b equals c squared for both triangles. So I'm going to have to do an a squared plus b squared is c squared here, and a different a squared plus b squared is c squared over there. So what do I know? The hypotenuse is the side that goes alone. That's the c. The hypotenuse is the c. So this is root 10 squared plus b squared is 9 squared. And the squaring cancels the rooting, right? They're opposites. That's square root of 100, which is 10, plus b squared is 81. Subtract 10 from both sides. B squared is 71. Root it. B is the root of 71. So b, which means the other side, is the root of 71. So I just bring that back up, and boom, there it is. Now on the other side, same thing. The c is the 9. That's the hypotenuse, right? Other two sides, a squared plus root 3. So it doesn't matter if you put the root 3 first. It's the a or the b. It doesn't matter at all. A squared. Now this cancels, right? Because it's square root of 9, which is plain 3. This is 81. Subtract 3 from both. So a squared is, what is that, 78. And then root it. A is the square root of 78. All right, so we got b, we got a. Let me bring that back up. A is the root of 78, right? Yep. So we got all three sides now in both triangles, right? For both triangles. Okay, step 4. Sohcahtoa to find what you need. What do you mean, what do I need? Well, back up here, remember, this is the whole reason we're doing. We're trying to find cosine B and sine A. So cosine B, we got to go to the B triangle. What's the cosine? Remember, cosine's adjacent over hypotenuse. Now we have those. It's going to be root 78 over 9. Cosine of B. Here, let me put it right here. Times root 78 over 9, right? Root 78 over 9 for B, for the B triangle, cosine of B is adjacent over hypotenuse. And then for the A triangle, the sine of A, sine is opposite over hypotenuse, opposite over hypotenuse from the A triangle. So that's root 71 over 9, and bring down the minus sign in the middle there. There we go. Now we got all the 4 parts we need. Now we can finish this problem. We just need to grab this messy thing and here, let me grab the whole thing here and bring it on down. So way down here, bring it down here. What was it? Root 10 over 9 times root 78 over 9 minus root 71 over 9 times, is it root 3 over 9? Was it that last one? Yeah. Okay, let's do it. How do you do this? Well, you just go straight and straight. So that's going to be the root of 780 over 81 minus straight, 3 times 71, 213 over, not 9, 81. Right, we good there? Now, we can put that together. The root of 780 minus the root of 213 over 81. But there's one more thing we need to do. It might take the answer like this. It might. But you can actually simplify the root of 780. I don't know if you remember how to simplify square roots. But if you break it down, it's 10 times 78, isn't it? And 10 here, I'm kind of running out of room on this one. 10 is 2 times 5. Whoops, that wasn't. Here, let me do this a little better. And so to simplify this, that's going to be 10 times 78, and that's 2 times 5, 2 times 39. And see how we have 2 2's here? So those 2 2's can send out a 2. Do you remember how square roots work? So this is the square root of 2 times 2 times 5. And the 39 is 3 times 13 if you break that down. Right? You get rid. So you break it all the way down to primes. I don't know if you remember all this. 2, 2, 5, 3, 13. You break it all the way down to the prime numbers, and then anytime there's 2 of something, that sends 1 out. And they're gone. So that's 2 root of 5 times 3 times 13, which is 2 root of, if you multiply that together, boy, this is getting ugly. 15 times 13, I'm getting square root of 195. So that becomes that. So this is a painful problem. So the square root of 780 becomes 2 square root of 195 minus the root of 213 over the 81. The reason I didn't break down the 213 is because I just know if you broke it down, there wouldn't be 2 of anything to do a 2-for-1 send out. That's what square roots do. They do a 2-for-1 ship out. Now, they might have taken it this way. I don't know. You could try it that way. They probably would. They probably would. Take it either way. I'll just say or. Both of those are good answers. You might not have to simplify that square root of 780 like I did in the end. I hope that's not surprising for you. 2 2's inside sends 1 2 outside. That's what roots always do, right? Like think about what's the square root of 9? It's 3. Why? What's in a 9? 2 3's, right? 2 3's in, 1 3 out. That's what square roots always do. 2 in, 1 out. So 2 2's in, 1 2 out. That's what roots always do. So anyway, long story short, that was a long problem. There it is. There is the exact answer for cosine of a.